Hey, everybody. Happy Monday. Hopefully, you're watching this on Monday, or maybe you're watching it on Friday because you went to go take a look at it and get ready for the test next week or something like that. But anyway, happy day, whatever day it is. Today, we are going to take a look at a new shape. It's called a pyramid. I'm sure a lot of you have heard of this thing called a pyramid, like one of those things in Egypt. In fact, we'll actually take a look at a problem like that later in this week. But first, we got to talk about the general parts of pyramids. And so when I have a pyramid, no matter what shape the base of the pyramid is, we do have a base. The base is, well, the side that's usually on the bottom. I suppose I could take a pyramid and flip it upside down, but the base could be a square, the base could be a triangle. As we saw on the previous slide, the base could be a hexagon. The base could be lots of different things. But for us, at least for today, we're going to focus on a specific type of triangle, or excuse me, a specific pyramid that has a square base. That's going to let us focus on the new things that we need to do today. So square base most of the time. All pyramids have lateral faces that are triangles, and that's the distinctive part of a pyramid. Now, if it's a regular pyramid, if all of the triangles are congruent to each other, then the pyramid has a vertex that is straight up from the middle of the base. Just like with a prism, usually the bases were perpendicular to the lateral faces, but they don't necessarily need to be. Usually the lateral faces were rectangles, but they could be parallelograms. For a pyramid, the lateral faces are always triangles. Usually they'll be isosceles, but they don't need to be. Um, we're going to have two different types of height when I look at a pyramid. The one that we refer to just as height is the perpendicular distance. I've said many times that the height has to be perpendicular to something. In this case, it's perpendicular to the base. Think of it like a flagpole that sticks straight up out of the middle of the base. And I'm going to call that h. I usually use a lowercase l to stand for the height. The other height we need to talk about is this thing. I've got it as a pink dotted line over here. This is called the slant height. You can think of it as the height of this triangular face. It's not straight up and down. It is not perpendicular to the base, but it is perpendicular to the bottom of that triangle. Just like always, we're going to use the slant height as we are figuring out areas. Slant height is going to be useful for areas of these lateral faces. The height is going to be what we need for the volume calculations. And then finally, do not forget the Pythagorean theorem. That was a big deal for us earlier, and the Pythagorean theorem is definitely not going away. In fact, it's such a big deal that I'm going to take just a moment and review it with you. Make sure that you remember what it is. In a right triangle, a triangle with the right angle, I'm going to call the two legs of the triangle A and B. Those are the two sides that are next to or adjacent to the right angle. The side that is opposite the right angle is the hypotenuse, and I usually call that C, at least when I'm talking about the Pythagorean theorem. And the Pythagorean theorem says the length of one leg squared plus the length of the other leg squared is equal to the length of the hypotenuse squared, better known as a squared plus b squared equals c squared. And we are going to see this Pythagorean theorem used a lot in this section. All right, the new formulas for us when I'm doing pyramids. The first one is the lateral area. And just keep in mind that this is the area of those lateral faces. And because on a pyramid, the number of faces is determined by the number of sides of the base, the lateral area is just this triangle plus that triangle all the way around. So in my formula, when you see the number of lateral faces, this is just counting. I've got four faces, four lateral faces, or six lateral faces, or three lateral faces. And then this base times height divided by 2. Now that's the slant height, remember, the height of that triangle. This is just the area of a triangle. So this is the area of one triangle times this many lateral faces. Now, that's the way I usually teach this, because usually I have my students memorize the formulas from this chapter. But because of our unusual circumstances this year, I am going to let you use your notes, which means most of you are probably going to just keep this as your formula. But the number of lateral faces times the length of the base, that's just the perimeter of the base. And so this does simplify down to perimeter of the base times the height. Oh, I should change that. That should be the slant height. And I usually use a lowercase l, but I put an italics on it, a lowercase kind of scripty l. So perimeter of the base times the slant height divided by 2. That is the lateral area. Surface area, predictably, if you think about this for a moment, you've got the lateral area plus the base. Now this is different from a prism because with prisms we had 2 bases. So because for a pyramid we only have 1 base, we only add the base 1 time. So when you ask the question to be or not to be, if it's a prism, it's to be. For a pyramid, it is not to be. It is just 1b. My son is listening to me say this and he is shaking his head out of embarrassment, but hopefully some of you Shakespeare fans are a little bit humored by that. The last formula we have to take a look at is the volume of a prism. Excuse me, the volume of a pyramid. And I said volume of a prism because I've got it on my sheet right now. This is base times height divided by 3. The volume of a pyramid is 1/3 of the volume of a prism. And I've got a YouTube link down here. I'll actually put the link on Schoology so you can go and take a look at it. It's just a quick little 2-minute video that explains or that shows that if you have 2 shapes, one of them is a prism, the other one's a pyramid, if they have the same base and the same height. The guy in the demonstration in this video, he fills the pyramid up with water and he dumps it into the prism, and it takes 3 pyramids to fill up 1 prism. If we were in the same classroom, I would stand in front of you and do the same demonstration, but we are not in the same room, so I'll just put the link on Schoology, and you can take a look at that if you don't believe it. But that is the formula. All right, so we've got these 3 formulas. The lateral area is the number of lateral faces times the base length times the slant height, or if you want to remember that as the perimeter of the base times the slant height divided by 2. That one works just as well. For the total surface area, lateral area plus the base, and the volume of a pyramid is the base times the height, area of the base times the height divided by 3. All right. So keep in mind, the lateral faces are triangles. That might help you remember that formula. There's only 1 base on a pyramid as opposed to 2 on the prisms, and the volume is 1/3 of the corresponding prism, the prism with the same height and base. All right, so all I have left to do with you guys today is to go through a few different examples. I've got 3 examples, and they'll be pretty representative of what you're going to see in the homework assignment. First one, if the height of this square pyramid is 4, okay, the height is 4, the slant height is 5, that goes on this one over here. Find the lateral area, surface area, and volume. All of these problems that I do here now and in the homework are going to look like that. Find the lateral area, surface area, and volume. One thing that I want to label on here is that we need to know how big this base is to find the area of the base, to find the perimeter of the base. I need to know how long these sides are. So here's where the Pythagorean theorem comes into play. I know the height is 4 and the slant height is 5. And so that means this length right here is the 3rd side of this triangle. Remember, this is perpendicular. The height is perpendicular to the base, so this is a right triangle. I'm going to put an X there. I'm going to switch what my pen looks like so I can put an X that's not a dotted line. And so my Pythagorean theorem is going to start with x squared plus 4 squared equals 5 squared. I'm going to skip ahead to my written out notes here. So this is the triangle that I'm looking at inside of this pyramid. Again, this length right here, that's what I am calling x. We know the height is 4, the slant height is 5. So we send it through the Pythagorean theorem. X squared plus 4 squared equals 5 squared. When I go through that, you can see the process that I've got here. I get x equals 3. And then finally, if x is equal to 3, well, this distance, if this point right here is the middle of the base, well, then this distance is half the length all the way across this. So if this is a square, it's the same length all the way across. 3 is half of 6. And so that side length, the length of the sides of the base, are 6, which means if I want to find the perimeter, 6 plus 6 plus 6 plus 6, or 6 times 4. And finally, the area of the base, 6 times 6 to get 36. And at that point, I have everything that I need. So I'm going to go straight to my formulas. Lateral area is the perimeter of the base, 24, times the slant height. That was 5, divided by 2. Plug that in a calculator to find 60. Total surface area, take the lateral area plus the area of the base. That came from 6 times 6, get a total of 96. And then finally, the volume is area of the base times the height of the pyramid, divided by 3. And I got 48 for that one. So there we go. That's how these problems are going to work. Most of the work comes in finding different missing sides. And then once you've got that, you can plug everything into the formulas. All right, next one I want to take a look at. On this one, I'm given that the base of this pyramid is a 10 by 10 square. So these lengths are 10. The height is 12. You can see the diagram is not proportional, but that's all right. It's actually not all that bad. They want me to find the same things. Well, here we go again. I need a missing side. I need to know the slant height. That's going to give me my lateral area and then eventually my surface area. So I'll do the same thing that I did before. I'm going to finish off that triangle and say that if this side length is 10, then the base of this triangle over here must be half of that because the height goes straight from the center of the square. So if this side length is 10, then that base of the triangle is 5. So there we go. 12 squared plus 5 squared equals my slant height squared. I'll put a script L right there, but then I'll send it through the Pythagorean theorem. 5 squared plus 12 squared equals slant height squared. Write down the numbers, hit the square root of 169 in your calculator to find that the slant height is 13. Now, I didn't need that for these two, but these are two things that I need before I go to the formulas. So I've got my slant height, perimeter of the base, 4 times the side length for 40, and then the area of the base, side squared because it's a square. So that's 100. And then off to the formulas. The lateral area is perimeter of the base times the slant height divided by 2. I got 260 for that. My total surface area is the lateral area plus the area of the base. That's how I got 360. And finally, the volume is area of the base times the height of the pyramid divided by 3 for 400. All right, and then the last problem I want to take a look at, the information that I'm given, again, is a little bit different. For this one, I'm given that the lengths of the sides of the base are 12 by 12. The slant height is 10, so I'm given the slant height. I'm given the length of the base, and I don't know what the height is. So there's my unknown this time. Well, hopefully you're getting the idea here. If this side length is 12, then half of that, the bottom side of that triangle, is going to be 6. And there's my Pythagorean theorem. 6 squared plus h squared equals 10 squared. I'll send that through the Pythagorean theorem. 6 squared plus h squared equals 10 squared. 6 squared, 10 squared. A little bit of algebra here. You got to subtract 36 from both sides. We get h squared is 64. Square root of 64 is 8. And now we have our height. Perimeter of the base, length of the base times 4 sides, or 12 plus 12 plus 12 plus 12 if you prefer. And the area of the base, 12 squared, 12 times 12 for the area of 144. And there we go. We've got all the same information. So hopefully we're getting better at this as we go through these examples. Lateral area is the perimeter of the base times the slant height divided by 2 to get 240. Total surface area is the lateral area plus the area of the base that we found on the previous slide for 384. And finally, the volume is the area of the base times the height, the straight up and down height of the pyramid, divided by 3 for 384. Something that I want to point out. In the first example that we did, the number we got for the surface area was twice as big as the volume. For the second one we did, the volume was bigger than the surface area. And then for this last one, the number we got for the surface area is equal to the number we get for the volume. I sometimes have students who think that one of them needs to be bigger than the other, and this is simply not true. It's apples and oranges. To say that the surface area is bigger than the volume doesn't even make any sense. The number that represents the surface area may be bigger or smaller, but the surface area is square units, feet squared, inches squared, miles squared. And the volume is in cubic units. We're looking at centimeters cubed, inches cubed, but they're definitely not the same thing. So we can't say one is really bigger than the other. We can just say that the number may be bigger or smaller. All right, well, there we go. Those are examples. Tomorrow we'll have a similar set of problems, but the information that we're given is going to be different. Maybe I tell you what the lateral area is, and we'll have to work backwards, just like we did for prisms and cylinders. So there we go. We will be working through this week. Expect a test sometime next week. Hope you had a great weekend, and hope we have a great week together this week. As always, if you need to get in touch with me, if you need to set up a one-on-one Zoom meeting or something like that, or if you want to send me an email or a message on Schoology, or however you would like to get a hold of me, that would be great. I will, well, y'all know where to find me. So I'll wrap it up and say have a great day, and I'll talk to you later. Bye.